The key to graphing a proper rational function is to understand what the numerator and denominator actually mean. If you can find the zeros of the numerator, you will find the zeros of the function. In other words, where it crosses the x-axis. So those would be your x-intercepts. If you find the zeros of the denominator, you will find your vertical asymptotes. That's the lines that it will not cross. So to do number 6, we simply find the zeros of the numerator. Obviously, what number could you punch into x plus 3 to get it to equal 0? X plus 3 equals 0, just set it equal to 0. And you can solve, and of course that will equal x equals negative 3. Do the same thing with the denominator. You can say that x squared minus 4 is equal to 0. Solve that, move the 4 to the other side, x squared equals 4. Take the square root of both sides, and you get positive or negative 2. So what we have now is the zeros of our function and the asymptotes of our function. And these are very easy to graph. You have a 0 at x equals negative 3, so that would be right here. That means the graph will cross that particular point. You also have two vertical asymptotes, one at negative 2 and one at positive 2. And now this is where a little bit of intuition needs to come in. You need to look at your graph and realize that this particular graph is a positive graph. Notice that the lead coefficient in your numerator is positive, and so is the lead coefficient in your denominator. Since they're both positive, this is a positive graph. So if we start all the way on the right side of the graph, we realize since it's a positive graph, it has to start positively. It has to start in this region, and it cannot cross those two lines. We know it can't cross the vertical asymptote because that's the definition of a vertical asymptote. We know it can't cross this horizontal asymptote because there is no 0 over there. The only way it can cross the x-axis is for there to be a 0. There isn't, so it has to stay in that region. So, in order to graph this, it's real easy. It approaches both of those asymptotes. Now, hopefully you remember from our previous lesson that you can, when you come to an asymptote and you're moving across the graph, anytime you come to an asymptote, it's going to flip to the other side. So here it's going up, so now it's going to go down on the other side. Well, it's going to start down here, but there's really nowhere for it to go. Once again, it cannot cross here because there's no 0, and we've got two asymptotes. So there's only one thing for it to do, and this is where you can sort of logically figure out how to graph these. And you can figure out how to logically graph it this way. Now, there's one more thing that I would really like to do here, and that is to go ahead and figure out where your y-intercept is. That way you can figure out sort of how high up and down that particular graph goes. Remember, a y-intercept is always found simply by plugging in 0 into the function. So if you punch in 0 here, 0 is x, that's 3 over 0. So that would be negative 3/4. So it looks like we hit it pretty closely when we graphed this to start with, but we should have probably gone all the way up there to that 3/4. Once again, being as accurate as you can. Although these don't have to be perfect, it is nice to be very accurate as much as you can, hitting those zeros and intercepts as well as possible. Okay, so now we go over another asymptote as we're moving right to left on this graph, and so we flip to the top side. Now there is one little goofy thing about this one. This one will start up here like normal, but it does hit that 0, which means that it will actually cross down to the negative side. It will still treat the x-axis as a horizontal asymptote, but it will cross down first. There's really not a great way to graph that other than just cross through and then start getting close to the x-axis. But this is how it works. Once again, find the zeros of the numerator. They tell you the zeros of the function, the points where they cross. Then find the vertical asymptotes by finding the zeros of the denominator. Those are vertical lines that it will never cross. And then from there, just use some simple logic of where it can and cannot go. Notice since it is a positive function, it must start in this region, so sort of graph it there. Every time you cross an asymptote, flip to the other side. In this case, we had an advantage of being able to find the y-intercept just by punching in 0 for our x's. And then, every time you cross those asymptotes, flip sides, and make sure you cross through the zeros like we did at this point.